Okay, 8th graders, today we're approximating square roots, and our essential question is, can you find decimal approximations of square roots that are irrational? And we did talk about rational and irrational numbers already this year, but let's review what those words mean. First, what is a rational number? And it's a number that can be written as a fraction. And in its decimal form, it either terminates or repeats. An irrational number cannot be written as a fraction. And as a decimal, it never ends and never repeats. And any number that we square root that is not a perfect square is also irrational. So rational numbers are most everything. Irrational numbers as decimals never end and never repeat, or they're square roots that are not perfect squares. Real numbers are all rational and irrational numbers. So we have a little chart here. Real numbers are either rational or irrational, so we have two different circles here showing rational and irrational numbers. Real numbers could also be integers, and then the natural numbers, which of course are what you're trained to count, so what you remember as a little kid. How do we count? 1, 2, 3, 4. Those are your natural numbers. Integers are positives and negatives, and they're always whole numbers. And then all rational numbers are decimals that either end or repeat. Our examples of irrational numbers are pi, the square root of 2, because it's not a perfect square. So that means the square root of 20, or the square root of 300. Those are irrational numbers because when we square root them, they do not come out perfectly. Anytime we do a square root of a number that's not a perfect square, we end up with a decimal that never ends and never repeats, just like pi. Alright, so turn your paper over, and we have a chart here of some numbers, and you're going to tell if they're rational or irrational and why you decided on that. So the square root of 12, if I type in the square root of 12 on my calculator, I get 2 square roots of 3, and if I hit the change button that's right above the enter sign, I get 3.464101615. And it keeps going, it never ends, it never repeats, so it's irrational because it's the square root of a number that is not a perfect square. Negative 0.36444444. These 4s are going to keep repeating and repeating and repeating. So since it's a repeating decimal, it's rational because it's repeating. Negative 1 3/7, that's a fraction. And we said any number that can be written as a fraction is rational. .85, that ends, so it's rational. It's a terminating decimal. .1212121212 is rational because it's repeating. Negative square root of 196. So if I type in to my calculator negative square root of 196, I get negative 14. So that's rational because it's a perfect square. Comes out evenly. And then the square root of 2, if I type that into my calculator, I get 1.41421, and it goes on and on and on, and it's irrational because it's not a perfect square. Alright, so you're going to have to classify numbers into rational or irrational categories and tell me why you did put them in whichever category you put them into. You're also going to have to estimate your square roots to the nearest integer. So if we're estimating the square root of 52 to the nearest integer, an integer is just a whole number. So square root of 52, I type it into my calculator, and I get 7.2111, and it goes on and on. So if I round it to the nearest whole number, is it going to be 7 or 8 is what you would ask yourself, and in this case it's going to be 7. So the square root of 33 gives me 5.7445, and it goes on. And so I asked myself, will this round to 5 or will it round to 6? And because we have a 7 here, 6 is the nearest integer. Square root of 85 is 9.2195, and on and on and on. So that would be 9 because the 2 tells me to keep it. Square root of 190 rounds to 13.78. So my 7 tells me to add one more to my 13 and make it a 14. And my negative square root of 7 gives me negative 2.645. And my 6 tells me to round my 2 to a negative 3. On the next set of problems, we have to tell which is greater. Square root of 5 or 2 3/4. Again, I can change them both to a common form, so I'm going to change them both to decimals. This one is 2.236, and 2 3/4 is 2.75. So 2 3/4 is greater. Here is 0.6 repeating, or square root of 0.36 greater. The square root of 0.36 is 0.6. So to compare these, this has 2 more places after the first 6, so I'm going to fill these in with zeros. Is 666 greater or is 600 greater? 0.6 repeating is greater. 4 1/5 is 4.2, and the square root of 23 is 4.79. So the square root of 23 is bigger. And the last one is pretty obvious. The square root of 10 or the negative square root of 5. The square root of 10 has to be bigger, because this one's negative. Alright, let's take a look at a real world problem. The distance in nautical miles you can see with a periscope is 1.17 square roots of h, where h is the height of the periscope above the water. Can a periscope that is 6 feet above the water see twice as far as a periscope that is 3 feet above the water? Well, a periscope that's 6 feet above the water could see this far, and a periscope that's 3 feet above the water can see this far. So we need to test each of these out and see if the square root of 6 is twice as far as the square root of 3. So I type into my calculator 1.17 square root of 6, and I get 2.87 when I round it. And then I do 1.17 square roots of 3, and I get 2.03 when I round it. So is this double this? Obviously not, so my answer is no. And then if you use a periscope that is 10 feet above the water, can you see farther than 4 nautical miles? So I'll fill in 10 for my height. And I get 3.70 when I round. So again, my answer is no, I can only see 3.7 nautical miles. Alright, turn your paper over. Your homework assignment is to go ahead and try each of the problems that you see. So tell whether the number is rational or irrational and explain on the first 3. Estimate to the nearest integer on the next 3. Which number is greater out of the 2 that are given to you? And then on 10 and 11, I want you to take a look at those and try them, but we will go over them tomorrow in class. Have a great night.